Hi everyone, welcome to another PSC video. Today we are going to discuss a problem named ln and frequency. Let's move to the discussion part. It's saying Alan Turing, the mathematician, is trying to break the encrypted messages of the German troops generated by their encryption device named Enigma. To find the distribution of characters, he needs to find out how many times a particular character appears in the string. So this is how many times a particular characters appear in the string. So, but to feed the data into his computer, Christopher is his computer's name, okay? So he needs the data in lexicographic orders, that is in alphabetical order. Since he is busy making Christopher better, he asks for your help. Help Alan find the frequency of characters in the encrypted strings in alphabetical orders, okay? This is also to keep in mind alphabetical order. The strings can only be in lowercase alphabets on, okay? So talking about the input, the first line contains n, the length of the string. N is the length of the strings, and the next line will contain the string itself. Like here in the sample input, 4 is the n value, and we can see the string's length is 4 because it have 4 characters only. And in the output, we can see that as in the string a, there's 2 occurrences of a, so a frequency is 2. And then as it was asked to keep it in lexicographic order, after a comes m, because n comes after m, so that's why. So and m's occurrence in the string is 1 only, and the occurrence of n is 1 only also. That's a 2, 1 and 1. Let's go back to a problem. Let's first add the givens. What are those? A string is given and we need to calculate the frequency of character in alphabetical order again, okay? Alphabetical order. Next is, let's go to the approach. So first let's understand the characters in terms of integer. I will tell you why. You will be able to relate. First, let's understand this. So a character can be represented in integer by using its ASCII value, ASCII value, okay? What is that? That is for A, the ASCII value is 97. For B, the ASCII value is 98. And all the way to Y's ASCII value is 121, Z ASCII value is 122. Okay, there are 26 characters, so I'm not going to show each of them. Okay, so if alphabetical order is our concern, as I highlighted you while reading the question, we need to do it in alphabetical order. Okay, so we can see that ASCII values also increases in the same order as characters. That is, A is less than B, and ASCII value of A is less than B's ASCII value, and so on. Okay, like we saw for Y and Z also. For Y it was a 121, and for Z it was 122. Okay, so by that point, we can reach to the idea that we can use hashing. I will tell you why. Because if a character can be represented by an integer and as indexes are nothing but integers, so we can just represent a character in terms of integer character equivalent to integer index in an array. That's what our idea is. Okay, we will see here. Use hashing to find the frequency of the characters in order. Okay, that is, a can be represented as ASCII value of a minus 97. Okay, 97 because a's value is 97, so 97 minus 97 will become 0. Okay, so means index is 0. Okay, ASCII value of a 97 minus 97 will become 0. Okay, similarly for b, it is ASCII value is 98 minus 97 will become 1. C 99 minus 97 will become 2. So A can be represented by 0 index, B can be represented by 1 index, and C can be represented by index number 2, and so on. Okay, so characters can be represented as integers, and that too as indexes of an array. Okay, that's what we are going to do. Now I have written it as it is. So index 0 means A, index 1 means B, and index 2 means C, all the way to index 25 it's Z. Okay, so now step 1 is traverse the characters in given string. Yeah, there's a string, so there are characters, so we will traverse them one by one and fill their count in our array at the respective indexes. Means if there is an A, so at index 0, we will put 1. I mean the count of total occurrence of 1. Okay. We will know the count by traversing the whole string. Okay. And that is count of A capped at index 0, count of B capped at index 1, count of Z capped at index 25. Okay. So that way we have frequencies of all the characters in the given string, and that too in alphabetical order. Okay. So till here it is achieved. Okay. What is achieved? Frequencies. Okay. Now step 2, traverse the array again and print the frequencies of characters, because we need to print them also, no? Yeah, that's all. Let's see how to do that. Go to the pseudocode. This is my function prototype. Okay. ln frequency, because these two are given only. Name is the frequency, sorry, a string. Okay, given, name string given, that's why I kept it name, and this is the length of the string. Okay, frequency is our array. It's going to be our array where I am going to store the count, because we know there are 26 small case characters in total. That's why I have taken 26. Okay, 0 to 26 means 0 to 25. So frequency of I, initializing we are 0. Okay, initially it is 0 because till now we don't know any occurrences of any character. Okay, so moving on. Now we are here traversing the string. Okay, because where till where I am traversing 0 to n. Okay, so before that I want to find the index. Index is nothing but a representation equivalent to character. Okay, representation of character in integer. Okay, so to do that I need to first find the ASCII value of the character and then subtract it from 97. I mean subtract 97 from that. So name is my character, string. Then character codat is the function which is going to give me the ASCII value for what? Of character at ith index in the string. Ith index in string. Okay, string is what? We have already written the string name here. Name. Okay, so it will give the ASCII value of the character at ith index in the string name. Okay, minus 97. We saw it already how it is going to be a an integer. So for a it will be 97 minus 97. 97 minus 97 equals to 0. So now we know the index of the character. Okay, so at that index we will just increase the counter. Initially it was 0, so it will, on first occurrence it will become 1. Okay, now so that way we can have count of frequencies of all the characters. Okay, now in the second part, coming to the second part, this part is for printing. How we are checking in the frequency array for what index the values are not 0, because 0 means occurrence never happened. So if it's not 0 means it occurred in our given string. So if it occurred, so let's see the output again. We need to print the character hyphen their frequency. So how to print the character? Because we know on the index. Same thing. We will just do that in the reverse direction. We converted character to integer. Now we are going to convert integer to character. How? We will get the ASCII value. How to do that? Because for a, let's say I was 0. So 0 plus 97 gives 97, which is the ASCII value of a. So, and this function, this function will convert that ASCII value to the string, sorry, character. So this will give me a. Then I am printing a hyphen, a hyphen, and frequency of a, because a is at index 0. So frequency of 0. So a head count equals to 2. So a hyphen 2 will be printed. Similarly for all the other occurred characters. Okay, it will be printed. Now moving on, let's say in the Aman, okay, what was the indexes for these? I mean in this part it became 0. So frequency will become, instead of 0 it will become 1. For m 12 at index 12, from 0 it will become 1, at index again 0, because previously we did change the counter to 1, so now this time it will change from 1 to 2. Here it will change from 0 to 1. Okay, so now 1, 1, 2 and 1. No, not just 1. Okay, because a is occurred 2 times. So at index 0 it's 2, and index 12 it's 1, and index 13 it's a 1. Okay, so this is the way how the frequency array is going to be traversed, and this is the actual way how it is going to print, like a hyphen 2, m hyphen 1, n hyphen 1. Okay, that's how it is going to print. Okay, so now about the time complexity of this, big of n. Only one, I mean, only for loop worked till 0 to n only, na? So that's a order of n. N is what? Because n we can say that not exactly. If we are going to compare, so max of n comma n actually. Why? This n is 26. Okay, for characters frequency. Okay, and this n is length of string. That's why. Okay, and for the space complexity, it is order of small n. Small is nothing but 26 as characters. Okay, because that's the extra space we use to store the frequencies. Okay, yeah, so that's all for this class. I hope you understood it too well. We'll meet you in the next class. Thank you.